All right. So this gave me a chance to erase the board and kind of write everything up anyway. So sorry for the interruption. I thought I had my phone on silent and I didn't. Not a professional video maker here. All right, so you want to kind of pause. We're still in section 4.8. This is the more complicated of the two types of things we're going to see. And I want to relate something that you already know to this new piece of dividing by a polynomial that has two terms. So here we go. Think about if you were going to divide 5 into 843. What would we do first? Well, we would divide that 5 into that 8. So we would divide into the first term. So in our steps to apply that same idea here, we're going to divide our first term into the first term. So 5 goes into 8 once. If this was our problem, what would we do? We would now multiply. We would go 1 times 5 is 5, and we put it right underneath here. 1 times 5 is 5. So we would multiply. Now this step does get just a little tricky because we need to multiply by both terms, which will be one little difference when I come over here. Think about what I would do next here. I'm going to change my sign or subtract the 5. I'm going to go 8 minus 5 is 3. So the opposite of subtract is adding, well, let me rephrase. A different way to say subtract is to do the opposite. So we're going to change that sign. We're going to write down the opposite sign. And then we're going to go 8 minus 5 is 3. What would we do next? Oh, let me write that down. Change the signs. And then we're going to add. Okay. What would we do next here? We're going to bring down that 4 straight down. So bring down the next term. And then think about what we're going to do next. Why don't we just repeat the steps over again? Now we're going to go, okay, 5 goes into 34 6 times. So we basically just start over again, back up to the beginning. 5 goes into 34 6 times, multiply it through, change the signs and add them, and bring down the next term. 5 goes into 43 8 times, multiply it out, change the sign and add straight down. There is nothing further that we can do to this particular problem. There's no further terms or numbers to bring down. And so this is our remainder. So depending on how you learn to write it, you can write remainder 3. When we have the harder problems like this, we're actually going to write it as a fraction. We're going to write it as 3/5. This goes in the numerator, and that right there goes in the denominator. So let's apply this idea over here. So we're going to have x plus 3 divided into x squared plus 5x plus 6. Step 1. First term into first term. So we're just going to divide x into x squared. X squared divided by x. Remember, we're going to just subtract those exponents. So x squared divided by x is x. Then it says multiply by both. So I have to actually multiply both of those. That's a real easy step for students where this is a new skill. It's real easy to forget that step. So that's why I start it, multiply by both. So x times x is x squared. X times 3 is 3x. Change the signs. So I've got a positive and a positive. I'm just going to override that with a negative and a negative. Maybe take that out right there. Draw my line. Add straight down. You want this first piece to go away. X squared minus x squared goes away. 5x minus 3x is 2x. And then we're going to bring down the next term. So bring down the next term, and then we're going to go back up to the beginning. So if I lost you in that first round, maybe circle back, try to watch this part, maybe it'll make a little more sense. X, divide first term into first term. X goes into 2x 2 times. If I just kind of scribble that out real quick, those x's would drop out. All right, multiply by both. So that 2 is going to get multiplied by the x. That 2 is going to be multiplied by the 3. Change my signs. Don't forget to change both signs. Okay? And then when I add these straight down, you can see everything drops out. If you don't have a number right there, you have a remainder of 0, and that's your answer. So I made the first example work out perfect. Let's do it again. I'll leave the steps up here. I'll erase this. And I'll just set it up right away so that we can just jump right into the divide. So our example B, if you will, is x squared. Well, let's do x minus 5, x squared minus 3x minus 12. And this is it can be a very tricky skill for some students. This is not a skill that remains throughout our whole course. Factoring is definitely a skill that if you don't learn how to master the things we learn in chapter 5, it will come back over and over and over again. In fact, that skill never leaves. This is something that stays here temporarily, and so if you don't master this long division, it is not like, oh, you're going to do so badly in the rest of the class. Okay? All right, we're going to go first into first. X goes into x squared, x, multiplied by both. So I'm distributing that. Don't forget you need to change both your signs. So notice right here that negative changes to a plus. That drops out. We have a -3 and a +5, so that's now 2x. And bring that down. Repeat. X goes into 2x 2 times. Multiply through to both of these. So we're going to get 2x minus 10. Change the signs. This goes away. A -12 and a +10 is -2. There's nothing more to drop down. So this must be our remainder. And the way we write that is -2 over what our divisor is, x minus 5. All right, what happens if we don't have a polynomial where, please notice real quick, this has a polynomial in descending order with no terms missing, meaning we have x squared, we have x to the first, and then we have no x's in the back at all. So we have that constant term. If you are approaching an example where some of those terms might be missing, you need to add in some zeros. So for instance, let's say we have x to the third plus 1. Sorry about that. So let's say we have that kind of a situation. So here's exactly what I'm referring to when I'm saying that you don't have it in it's in descending order, but you're missing terms. For instance, when we go to set it up, go ahead and write that x to the third down. We absolutely need to write down an x squared term. Everybody needs to be here, but there isn't an x squared term, so we put a placeholder in as a 0. We don't have an x to the first term, so we put a placeholder in as a 0. And then the last thing left is our constant term, which is 1. All right, so now you're going to see me go through the steps 4 times because we have 4 terms to go through. So again, here are my steps. X into x third is x squared. Oops, x squared. Multiply it out. And that's why we do it this way, because now those line up, and we're not in a situation where those don't line up. Change my signs. Add straight down, so this goes away. We have 0 and we have a -1. Remember that constant right there is a -1, so I'm going to have -1 x squared. Bring that straight down, plus 0x. Repeat, first into first. So x goes into -1x squared, -1x times. If that's confusing to you, write it down like, write it down like that. And so there's nothing to reduce from those coefficients, and so 2 subtract 1 leaves 1 right here. All right. So I'm a big fan of kind of convincing yourself what I'm saying is true by kind of scribbling it out off to the side. All right, so we divided first into first. Let's multiply it through. So this times this is -1x squared. It's a -1x times 1, so it's -1x. Change the signs and add straight down. So that goes away. And we end up with 1x. Bring this straight down, plus 1. Repeat, first into first. Again, write it off to the side. What's going to happen? Those x's are going to drop out. So right up here, I'm just going to write a plus 1. Multiply it through. Change my signs. And when I add straight down, you can see that that divides evenly with no remainder. So this is the answer to the question. All right. Let me show you the alternative. It's called synthetic division. And once again, if there's just so many YouTube videos out there of math teachers trying and explaining more of these, so if you need a few more or you just need to hear it from a different voice, I would encourage you to go and search for those. I'm sure there are examples on MyMathLab as well. So synthetic division is the shortcut. So let's go back and take the first example that we did, because we already know what the answer is. So my example was divide x squared plus 5x plus 6 by x plus 3. All right. Here's what we're going to do. The first thing, this right here has to be a 1. Must be a 1. The coefficient in front of the x term must be a 1 in order for you to use synthetic division. I will only put problems on the test where that is a 1. You might see other problems in the homework for challenge, and it's always good to kind of practice something at a higher level of difficulty, but on the test I will only ever put a 1 right there. Okay. Step 1, take whatever that number is and write the opposite in a little box. So write -3 because this is a +3. And go ahead and put that like that. If you choose not to learn the shortcut and you're like, oh, that's too much, one more thing to learn, totally just use the long way. All right, then what we're going to do is we're going to write our coefficients right here across the top. So 1, 5, and 6. 1, 5, and 6. Leave a little space and draw your line. The great thing about this video is you can go back and rewind and watch me and hear my words over and over and over again. So step 1, bring down the first number. Then the only two things we're gonna do is we're gonna multiply diagonally and we're gonna add straight down. Okay, so we're gonna multiply 1 times -3 and we're gonna come up with -3 and we're gonna put that right there. We already brought this one straight down. 5 take away 3 is 2. We're gonna multiply diagonally. So -3 times 2 is -6, but we are gonna add straight down and we come up with 0. If you go back in your notes and ask yourself and look, what was the answer when we just did this one a few moments ago, you would see the answer was x plus 2. Think of our coefficients, where our coefficients are 1 and 2. 1 and 2. If this is x squared, this goes down by 1 power of x, and that's my final answer. Let me show you another one. And we'll just repeat this synthetic division. And I'll choose one that we haven't already looked at. So, synthetic division is not in the book. It's just something that math teachers kind of know as a trick, and so we like to show students how that looks. And so I just randomly picked that. I just came up with something. I don't really know what the answer is. I know it's going to not work out nicely because I know the tricks about polynomials that you'll learn in college algebra. So I know this will have a remainder, so then I have an opportunity to show you that. All right, so what do we need to write for coefficients? Well, we're going to write a 1. We don't have any x squared terms, so we're going to put in a 0. We have -2 for our x, and then a 1. We're going to leave a space, draw my line. Remember, we're going to do the opposite here. So if this is a -2 off to the side here in the little box, we're going to do a +2. We're going to multiply diagonally, and we're going to add straight down. So we're going to bring down that 1. We're going to multiply. 2 times 1 is 2. We're going to add straight down. We're going to multiply. 2 times 2 is 4. We're going to add straight down. We're going to multiply. 2 times 2 is 4. We're going to add straight down. And we're done already. So all of that division piece is out of the way. We just got to kind of interpret our answer. If this is x to the 3rd, this goes down by 1 power. So this is 1x squared plus 2x plus 2, and this is our remainder. So I'm going to show you how to write the final answer. I would write this as x squared plus 2x plus 2.